Thank you very much. Very exciting to be here. This is the region which is historically very rich with oil and gas. And here we are talking about the electrification of air mobility, and we are talking about the future. And we at ZeroAvia, we are providing this bridge between today and the future by bringing hydrogen into the aviation. I have a quite unusual background for aviation. I got a PhD in physics, in low and ultra-low temperature physics, and then worked many years in consulting. So I'm used to provide external view on how the industry is developing and how different pieces of the puzzle fit together. And this is one of the views which we can provide from the external, from the customer perspective. We saw an immense development in the industry in the last, let's say, 60 years. So the efficiency of the engines, which are powering now the aircraft, increased quite significantly from 60 to about 2000. And then going forward, you can see that the trajectory of improvement of efficiency of the turbine engines of the aircraft is kind of slowed down. So we can continue squeezing the engine, the last droplets of the efficiency, or we can do something different. And the industry can grumble about that it's unfair treatment, but the data shows the reality. And unfortunately, we believe that the innovation, the breakthrough, the innovation in the industry is not likely to come from the incumbents who are working on the turbine engines today. The reports from Intergovernment Panel for Climate Change shows that the challenges in transportation sector are quite significant, and that is transportation in land, ground, and sea. And this is exactly the topic of our conference here. So the air is probably the toughest one. And the reason why is because we all want to fly. Probably most of us here in this audience actually flew here. Without air connection, we wouldn't be here. We wouldn't go to different places. We wouldn't be connected to the world. And unfortunately, or fortunately, more and more people can afford flying. And if you look at all these projections in terms of the increase of air travel, and as you saw on the previous graph, with the slowdown in terms of the efficiency gains from the traditional engines, we need to have a major disruption. We need to have a major disruption so that instead of being a major producer of the environmental impact from the aviation, which can grow from today's level of about 5 to 10% to about quarter to 50% if you don't do anything, while other industries are doing quite a bit on this front, we can end up as, again, the largest emitter of CO2 and other environmental impact. And this is a significant gap between where we are projected to be and where we want to be. We want to be at net zero. We want to fly electric. We want to fly hydrogen electric. We want to fly without any emissions in aviation sector. And unfortunately, the bad news is not over for the aviation. On top of the carbon emissions, we have a lot of other stuff, non-CO2 emissions, like nitrogen oxides, sulfates, particulates, and all this other emitted stuff is producing actually 2/3 of the environmental impact of the aviation. And the solution which is currently promulgated today by the industry is just use this sustainable aviation fuel. And unfortunately, sustainable aviation fuel, as you will see in a couple of seconds, only addressing the CO2 emissions and not the rest of the emitted stuff. I grew up in the Soviet Union, behind the Iron Curtain in the 70s and the 80s. And it was a privilege to fly. It was quite a rare event. It was not available to everybody. And we were not connected to the wider world. And, my first intercontinental or transatlantic flight was in the mid-90s when I went to America to do my PhD. And as I said, low and ultra-low temperature physics. And it was amazing how much the world opened for me. And I think it is, if you look today, this privilege is available to only about 10% of population. And if the trend will continue, and if we emit more and more, there are, of course, two possible solutions. One is to increase the cost and the prices, so the affordability of aviation will decrease, or we will try to somehow artificially limit the connectivity between people. And this is not what I want to do. I don't want to put an iron curtain on aviation. So this is of the paramount impact for us, for our company, to actually contribute to the decarbonization, so that the lights don't get turned off. And unfortunately, as you saw, the gap is quite big, and the innovation is needed and quite significant. And unfortunately, as I said, the incumbent turbine manufacturers and the engine manufacturers are not doing much, and we need to bring the innovation. And some people might say, you guys are crazy, to work with hydrogen because hydrogen is dangerous. I just heard this a couple minutes ago. And but the reality is that we need to dream big and bring our dreams into reality. If you look about 120 years ago, Wright brothers, they actually dared to dream and bring dream into reality. About 2 weeks before their first flight, New York Times actually published a paper that it will take millions of years for people to get to fly these big machines which are heavier than air. And in reality, this is what happened a couple of weeks later. They dared to dream, and they defied the status quo. They continued pushing what they believed, and this is what opened the new horizons for the humanity and brought people in the air. Unfortunately, or fortunately, again, we all want to fly, and the environmental footprint from aviation is going to only increase, unless we do something great and something big. And this is exactly what we are working on. We started to dream big about 7 years ago. So the company ZeroAvia was born about 7 years ago, and we had only a couple of people in California. That's where we started. We started to try our ground experiments with the flying El Camino. So basically, I put the electrical engine on the back of the pickup truck, and we were kicked out from our place where we were, doing the test because the permits weren't there. But we dreamed big, and this is and we already fly, and we'll talk about it in a second. But why did we start to work with hydrogen electric? Me and our early team, we came from electrical vehicle industry. You see quite a bit of the representation of that industry here at the conference. And of course, it was quite natural for us to think about, okay, let's take the aircraft, put electrical motor and batteries and start flying. And this was exactly what we did in 2018. But unfortunately, all the calculations showed that for long distances, this is not a scalable solution because the batteries are too long, it costs too long, they're too heavy, it takes too long to recharge them, and every single event of charging and recharging is coming at the cost. Therefore, we looked at the alternative, and of course, we are focusing on hydrogen electric. I will talk a little more about it in a second. But what are the alternatives? In a nutshell, the alternatives are pretty much the combustion of something, be that hydrogen combustion or sustainable aviation or synthetic aviation fuel combustion. So hydrogen combustion, for example, doesn't eliminate the rest of the 2/3 of the emission. The same thing is with sustainable and synthetic aviation fuel, which are called carbon neutral. So they emitting effectively zero carbon, but they are emitting all the rest of the 2/3 of the emissions. Therefore, we believe that hydrogen electric is the only solution. So, of course, we are biased. We are working on this technology, and if you want, you can go and look at other independent sources, which will tell you pretty much the same way. So, hydrogen electric, what does it do? We are using hydrogen in the hydrogen fuel cell to produce electricity, and then electricity similar to what you have in an electrical vehicle. Car drives the motor, and that provides the propulsion. So when we started doing this, people were saying that you are crazy because you will just create fuel from water, which is available, or from hydrogen and oxygen, and this is not realistic to fly a large aircraft. And this is exactly what we did. The only byproduct of this process is water, not no CO2, no other induced NOx and SOx and the rest of the good stuff which is currently emitted by the industry. So we have flown first the 6-seat aircraft in 2020. Then at the beginning of last year, we started to fly the larger aircraft, 19-seat aircraft, and we're still testing it. And the idea is that we will enter into the service in about 2 years, and you will see the commercial flights of this aircraft at the beginning of 2026. In parallel, we are developing all the components and everything to fly larger aircraft, so 40 to 80-seat aircraft, so that you can fly regionally with the distance more than 500 nautical miles. And with some of the changes, you will see actually the flights on the regional jets and the larger aircraft in the next 10 years. So, and going forward, for example, I'm based in UK, and I flew, on a big aircraft. With some of the revolutionary redesigns of the aircraft, you can actually see at the end of 2040s, at the beginning of 2050s, with the significant redesign of the airframe, you will be able to fly on hydrogen as well. So, as I said, the company now is testing its powertrain. We have flown more than a dozen flights. So we can proudly say that we joined the Hydrogen Mile Club. So we have flown, above the altitude of 5,000 feet. The longest flights so far are more than half an hour, and they're flying at the same speed as the stock aircraft. Now, where are we in terms of the development of the bigger airframe? So this is the aircraft which will be which can fit about 90 passengers, and we started already testing different components which will be able to propel this size of the aircraft in the air in the next couple of years as well. And the components which will go into this aircraft, they are scalable, and they will be able to be utilized for the larger aircraft as well. So we are at ZeroAvia. We are eliminating harmful greenhouse emissions. And we are not just cutting the carbon, but we are also cutting the rest of the emissions coming from the aviation. So it is truly clean, and it is truly a scalable solution, which is going to be available to everybody in the next couple of years. Not only it eliminates the pollution, but also what you saw from other exhibitors here, the electric propulsion is actually can be quite less noisy. So it will be benefits to people who live next to the airports, and even their quality of life will benefit from our operation. So we will keep the world flying. The connectivity. We will enhance the connectivity, so it is not going to be available to the 10% of the privileged, but to the 100% of the population. Thank you very much.